Today we're looking at composition of functions and inverses of functions. Your essential question is, how do I compose functions and how do I find the inverse of a function? Your learning intention, I'm learning to compose functions, evaluate functions, and find the domain and range of functions. So you've got two warm-up questions. You've got two different equations, and then you're supposed to evaluate according to what is being asked. Pause the video and do these two problems now, please. Well, I do hope you tried these on your own. If you're looking, we are looking for g, and we're going to use that function, and we know that the x value is -5. So I'm going to substitute -5 into g, my function g, and simplify. -4 times -5 plus 1 is equal to negative times negative is a positive. 4 times 5 is 20. 20 plus 1. So when I evaluate g with -5, I get 21. For the next one, we're using the function f. Once again, it gives us a value for x to substitute in. When x is 4, what happens? Well, you start off with 2 times 4 squared minus 3. So when I take my function f and I put 4 in, it becomes 2 times 16 minus 3. My function f evaluated with 4 is equal to 32 minus 3, which will give me 29. Okay, the what of a function f and g, written as f of g, evaluated with x, is defined as putting the g value into f, and we use the output of g as the input of f. Kind of wordy, isn't it? The composition of functions. When you compose something, you're going to put something inside of the other. So we'll see how this works in reality. Okay, the composition I've put, I'm looking at my function g. This is g. I'm looking at 0. 0. So when x is 0 in my table g, my output is 4. So this becomes putting 4 into f now. So 0 goes to 4, 4 goes to 7. So when I take and put g of 0 into f, I get 7. What happens if we go the other way, though? What if I use my table f? X is 0. 0 goes to 6, so this becomes g evaluated with 6. 6 goes to 2, which is 2. So when I take g and I put the value of f when x is 0 in, I get 2. Okay, what happens, these two mean the same thing. It's just writing it in a different form. I call this fog f of g. I call this f of g of 0. Both of them mean the same thing. So first thing I have to evaluate, when g, what in the table G, when x is 0, what is my output? 4. So this becomes f composed with 4, which is equal to 7. So f of g, fog, when x is 0 for the G table is equal to 7. And for the last one, we look at f of 5. This is where we're starting. Go to my table F. When x is -5, -5 goes to 8. So now I'm looking at G when my x is 8. I come down here, 8 is 0. So when I take G and I put F when x is -5 into it, I end up with 0. So let's take a minute. We're going to look at this again. I start with G of 0. 0 goes to 4. 4 goes to 7. This time I start with F of 0, where x is 0. When x is 0, 0 goes to 6. 6 goes to 2. This is the same as the first one. I'm going to start with f of -5. -5 goes to 8. 8 goes to 0. You are jumping back and forth between the two tables. So it's just bouncing you around. You have to know where to start and how to continue. So if we've got tables, we go back and forth. But what if it is an equation? Okay, I've got two different problems here. If you notice, they're quite similar. But this time I'm starting by putting B into A. This is B. And I start out, we're using substitution. So A of x, A evaluated with x, is the opposite of x plus 4. So this is going to become the opposite. Instead of x, I'm going to put 3x minus 5 plus 4. Take a minute and look at what we've done. Okay, distribute the negative sign. So the opposite of 3x is -3x. The opposite of -5 is +5 plus 4. We are almost done. So when I take my function A and I insert my function B, I compose it with B, then I end up with -3x plus 9. But what if I go the other way? What if I decide to put A inside of B? Will it be the same? This time I'm going to put this inside of B. So 3 in parentheses in place of my x, -x plus 4 minus 5. We're using substitution. So when I've got B and I put A evaluated with x inside of it, I get, distribute. 3 times -x is -3x. 3 times 4 is +12 minus 5. Ooh, I don't think I'm going to get the same thing. The first terms will be the same, but not the second. So when I take b, evaluate it with, put a inside of b, I get negative 3x. 12 minus 5 is 7, plus 7. So if you're still struggling, back the video up and watch it again. What is denoted as f to the negative 1 of x is a function that undoes the operations of the first function. This means that when I take my function, I find the inverse of the function, that it will take it back to x for all values in the domain of f of x. So these are inverse functions. So let's start with a table. A table is really simple. So I'm going to make my table here. This is going to be x, and this is going to be f inverse of x. All I do is switch them around. So instead of negative 5, 8, it becomes 8, negative 5. Instead of 3, 4, it becomes 4, 3. Instead of 0, 6, it becomes 6, 0. Do the next one, and the next one. 4, 7 becomes 7, 4. 2, 0 becomes 0, 2. All you do is switch them around. So the tables are quick and easy for your inverse. But what happens if you have a function that's written as an equation? Well, you're going to start by thinking of it as, instead of having h of x, we're going to use y. So y equals 2x plus 7. Your inverse means I'm going to switch the x and the y around. And then I'll solve it again for y. So I'm going to switch the x and the y. Those will change places. So x is equal to 2y plus 7. Now it becomes a two-step equation. I'm going to subtract 7 from both sides. X minus 7 is equal to 2y. Now I am going to divide by 2, and my h inverse is x minus 7 divided by 2. You switch your x and your y around and solve for y a second time. Okay, in this case, you want to switch them around, and x is equal to 3y plus 7 divided by 2. Step 1, multiply by 2. 2x is equal to 3y plus 7. Second step, subtract 7. X minus 7 is equal to 3y. Last step, divide by 3. So when I take k and I look for my inverse, it becomes 2x minus 7 divided by 3. So I hope it's not too confusing for you. I hope that you are able to do the practice. How do you know you're successful? When you can compose functions and you can find their inverse. So for today, it is composition, and inverse.